Hey, hello, welcome back. In this part, we are going to take a look at the FastCall calling conversion example. Okay, so here we have our function. Let me show you this function here. It's right here. Let me show you. Where is it? Yeah. Okay. So it's right here. It's right here, as you can see. Let me zoom a little bit so that you can see everything. Okay, so we have this function called my function, and it takes in two parameters, x and y. Okay, and it returns this expression. Okay, and it results into an integer. Okay, so like that. Okay, so this one is going to become like this. Okay, let me try to let me exit that one, and it's going to become like this. Okay, so it's going to generate this assembly code right here. Okay, so as you can see, we have public my function. Okay, my function, then we have it's in between the @ symbols, and then 8. Okay, 8 is the total number of bytes. Okay, that we're for the arguments or for the parameters. Okay, we are passing. Okay, and we have these the setup. As you can see here, we are setting up the stack frame, as you can see, using EBP and ESP registers. Okay, and then we have this we have this exit sequence right here when we try to move EBP into ESP, and then we pop EBP, and then we return 0 like that. Okay, so this listing is very interesting. Okay, and I want you to keep one important point in your mind, okay, before we start talking about this function. Okay, so this function was compiled with the optimization. Okay, optimization is turned off. Okay, and with that point in mind, let's examine it a little bit. Okay, so first the first thing we notice is that on line 4, which is this one, line 4, a standard stack frame is set up. Okay, and then EBP is decremented. Okay, EBP is then decremented by 8. Okay, and why does it do this? Okay, so the function might not receive the parameters, okay, on the stack, but the cl.exe code generation backend is expecting the parameters to be on the stack anyway. Okay, so this means that space needs to be allocated on the stack, and the parameters need to be moved out of the ECX and EDX. Okay, and moved onto the stack. Okay, so this is made even more ridiculous, okay, by the fact that parameter x is moved out of the ECX in the beginning, okay, of the function. Okay, and this is moved back into the ECX, okay, on this line, on line 5. Okay, right here. Okay, hopefully the optimizer would catch this nonsense, okay, if the optimizer was turned on. Okay, so it's difficult to determine which parameter is passed first, because they are not put in a sequential memory addresses like they would be on the stack. Okay, however, the Microsoft documentation claims that cl.exe passes first call parameters from left to right. Okay, so to improve this to prove this point, let's examine a simple little function with only one parameter, okay, to see which register it is passed in. Okay, so let us have another function. Let's exit this one, and we have another function right here. Okay, so we have another function called first test. Okay, and it takes in one parameter called z. Okay, and it returns an integer. Okay, and as you can see here, we are returning z times 2, like that. Okay, so here the cl.exe is going to compile into this listing that I'm going to show you. Okay, so let me bring it right here. Okay, let me bring it right there. Okay, so as you can see, public art first test art 4. Okay, like that. Okay, so 4 means we are taking in a parameter which is of size 4. Okay, like that. As you can see here, size equals to 4. Okay, and here we are having some setup. Okay, as you can see right there. Okay, so so it turns out that the first parameter passed is is in ECX register. Okay, as you can see right here, and we notice in our function above that the first parameter x was passed in ECX as well. Okay, before. Okay, so there are 4 parameters parameters are really passed left to right. Okay, unlike in CDECL. Okay, so let's we notice two more details. Okay, and the first one is that the name decoration scheme of the function art, as you can see, we are having art, then our function, then art, then the bits. Okay, the number of bits, the number of bytes. Okay, right there, as you can see. Okay, so from there we have another note, okay, that we should understand. Okay, so the rate this one, the rate zero function seems to show that the caller cleans the stack. Okay, but in this case there is nothing, okay, on the stack to clean. Okay, and it is unclear, okay, who will clean the stack. Okay, and from this listing, as you can see, we note down that one. Okay, so the rate zero function, okay, seems to show that the caller cleans the stack. Okay, but in this case there is nothing, okay, on the stack to clean. Okay, so if we take a look at yet one more mini example, let's remove this one, and we take a look at this example here. Okay, let's take a look at this example. We have a function called first test, and it takes in very many parameters. Okay, it has very many parameters. It has x, y, z, a, b, and c. Okay, like that. Okay, and it returns the multiplication operation of all these operators. Okay, like that, as you can see here. Okay, so and the corresponding listing is like this. So let me exit this one and I show you. Okay, so let me exit that one and I show you here. Okay, so let's take a look at this one. Let's examine this one here. Okay, so we can clearly see that in this case the callee is cleaning the stack. Okay, right here, as you can see, it's cleaning the stack. Okay, as you can see right there. Okay, which we can safely assume will happen every time. Okay, and an important point to notice about this function is that only the first 2 parameters are passed in the registers. Okay, as you can see here, only the first 2 are passed in the registers. Okay, y and z. Okay, like this, like that. Okay, y and z. Okay, they are passed to the registers, and the first of which is passed in ECX. Okay, the first is passed in ECX. So let's take a look at this one here. Okay, the first is passed in ECX, and then the second is passed in EDX. Okay, right there, as you can see right there. Okay, the past is passed in EDX. Okay, so all the remaining arguments are clearly passed on the stack. Okay, so in a right to left order. Okay, and it seems that the first 2 arguments are passed left to right, as you can see here. Okay, as you can see here, right here, as you can see, why here we are having -8 and -4, like that. Okay, so but all the remaining arguments are passed right to left. Okay, like that. Okay, so in the next part we shall take a look at some examples about the STD call. Okay.